Hello, my name is Mary Vosbury, and this is my presentation on the iodine clock reaction. The purpose of this experiment is to demonstrate chemical kinetics with two clear solutions being combined, creating two chemical reactions occurring simultaneously that then create a color solution in the end. The two solutions that I made was solution A, which consisted of vitamin C, 4 500 milligram tablets crushed, and then added distilled water to it, drained it through a coffee filter so that the floating particulates that did not completely dissolve were filtered out in order to get that clear solution, and then added iodine in there. The iodine ultimately goes into the solution as a color but interacts with the vitamin C to make it colorless. Solution B was cornstarch and hydrogen peroxide. Again, with the cornstarch, used coffee filters in order to get the excess cornstarch that did not dissolve with the distilled water, just to make it a little less cloudy. So those are the two solutions that we used for this project. Moving on to what ultimately happened with this. Took solution A and solution B and mixed them together. This caused two chemical reactions to occur at the same time. The first one being that the hydrogen peroxide wanted to interact with the I- ions, and then vitamin C interacted in order to keep the I- ions, and then the hydrogen peroxide actually consumed the vitamin C, meaning that interaction between the vitamin C keeping I- ions from changing didn't happen. This meant that the I- ions were made into I2, and then the I2 starts to accumulate because there is no more vitamin C, and then this makes a triiodine complex between the I2 and the I- ions, ultimately causing that color change that we see between the two solutions interacting. This color change roughly took me about a minute 15 to occur. My water wasn't really that warm, and I think that's why it took longer for it to change, and I'll discuss why that happens on the next slide. But it roughly took my reactions about a minute and 15 to happen. Moving on to things that can affect how long it takes for this color change to happen is first being temperature, which I talked about on the previous slide. If you increase the temperature of the solution, it will increase that color change, and then vice versa. You decrease the temperature, it will decrease the time. If you increase the temperature, it will decrease the time. So hotter solutions take less time for the color change to happen, whereas colder solutions will take longer, and I believe that's what happened with my reaction. The second thing is concentration. So if you have more hydrogen peroxide in your concentration, this will cause a quicker change because that hydrogen peroxide will encompass that vitamin C a lot quicker, meaning that I2 will accumulate faster and that color change will happen quicker. Whereas if you increase that vitamin C, there will be a slower color change because it will take longer for that hydrogen peroxide to overcome that vitamin C to enable those I2 ions to accumulate, creating that chemical change. But as long as the concentrations are roughly about the same, it will be about a minute for the color change to happen approximately. And that is my presentation on the iodine clock reaction. Thank you.